Q1 there, I'm going to multiply, right? So I'm going to get 120 Q1 minus Q1 square minus Q1 Q2, okay? Plus 120 Q2 minus Q1 Q2 minus Q2 squared. A lomba jinishta tomra paiso. Did you get this?
Yes.
Okay.
Yes, sir.
Now I am going to differentiate this with respect to Q1. Ami jokhon a function take, lomba function take, Q1 er sapekshe differentiate kori, what do I get? I will get 120, okay, term by term, 120. Tapra, what do I get? Minus 2Q1.
2Q1 minus 2Q1.
Yes.
Tapra, what do I get? Q2.
G, sir.
Tapra I get, okay, Q2 term gula vanish hoye jabe. Tapra last arekta Q1, Q2 ase, right?
Yes, sir.
So I get
Minus
another Q2, right? Another minus Q2, right? Ekhane duta minus Q1 minus Q2 ase, right?
Yes, sir.
Duta minus Q1, Q2 ase, right? So I'm going to get minus Q2 and minus Q2, okay? So that is equal to 0. So my result is 120 minus 2Q1 minus Q2 minus Q2 is equal to 0. Or 120 minus 2Q1 minus 2Q2 is equal to 0. Or I get, if I simplify this, I get 2 into Q1 plus Q2 is equal to 120, i.e. Q1 plus Q2 is equal to 60. এরকম একটা result আমি পাই।
Yes, sir.
Yes, sir.
Now, there is a little difference between this result and the previous result. এর আগের result I could figure out Q1 star and Q2 star separately. দুটা আলাদা value I could... Yeah, 80 হচ্ছে, right? এখানে I am not getting Q1 and Q2 separately. আমি একটা joint value পাচ্ছি, right?
Yeah.
Right? এখান থেকে আমি Q1 plus Q2 equal to 60 হলে I cannot figure out Q1 or Q2 unless I know the value of Q1, either Q1 or Q2. এখান থেকে তো আমি বের করতে পারবো না. So any values of Q1 and Q2, any values of Q1 and Q2 which sum up to 60 will solve the joint value problem. So what could be the solution? There is an infinite number of solutions as long as Q1 and Q2 plus added together is equal to 60. So it could be Q1 star could be equal to Q2 star could be equal to 30 could be a solution. 30 plus 30 is 60. Q1 star is equal to 40 and Q2 star is equal to 20 could be another solution. 40 plus 20 is equal to 60. Or Q1 is star is equal to 0. Well,
so there is no equal distribution or anything
no,
like
no,
that.
No. No, মানে equal হতেও পারে না হতে পারে. The key is we don't know the values of Q1 and Q2 separately. We know their joint value. We know their joint sum. But we don't know the individual values of Q1 and Q2. So any values of Q1 and Q2 which add up to 60 is a solution to this problem. So Q1 star is equal to 0 and Q2 star is equal to 60 could be another solution. Q1 star is equal to 60 and Q2 star is equal to 0 could be another solution, as long as they add up to 60 and so on. So what is the significance? What is the significance of this result? Some of you may have already guessed it, given the discussion we had a few minutes ago. Okay? Some of you may have already guessed it, given the discussion we had a few minutes ago. So in the preceding result, the result that we just saw, a total of 60 sheep would be grazed on the commons, whereas in the Nash equilibrium solution, a total of 80 sheep would have been grazed. Okay? So from the perspective of common resource depletion, the joint value result is superior to the Nash equilibrium result. So we calculated the Nash equilibrium result on the basis of best responses. But the joint value result, okay, is superior as a fewer number of sheep would be grazed. Why is that? আমরা একদম শুরুতে কি বলছিলাম? When it comes to depletion of a common resources, more is not better. Less is better, right? তোমরা যদি ওই field-এ you want to graze sheep, it is better to graze a fewer number of sheep rather than a larger number of sheep. আমি যদি এখানে 500টা sheep নিয়ে যাই, very quickly the resource will be depleted, right? So it is better to graze 60 sheep rather than 80 sheep. So we are going to compare this with the prisoner's dilemma. In the prisoner's dilemma, the Nash equilibrium outcome was betray, led to a lower payoff than silent, right? I don't remember what the payoffs were. I think the
Yes, sir.
betray was 1-1, and silent was 3-3 or 2-2, right?
Yes.
Right. So betray was 1-1, and silent was 2-2. So in the prisoner's dilemma, the Nash equilibrium was betray, and betray payoff was lower. So similarly, in the tragedy of the commons, it shows that the feature that sometimes a Nash equilibrium is less efficient for all players than some other outcome. Okay? Nash equilibrium is fine. The Nash equilibrium is important. Why is Nash equilibrium important? Because it is a stable equilibrium. If you come up with a Nash equilibrium, that equilibrium is very stable. And it is the equilibrium that will prevail. Alternatives may be more efficient from the perspective of payoff, right? But they are often unstable equilibria. In the prisoner's dilemma, silent, we already noticed that it was an unstable equilibria. If the other prisoner remains silent, তাহলে তো ভালোই হলো, আমরা দুজনেই বেঁচে গেলাম. But I don't know if the other prisoner is silent, right? আমি যদি silent থাকি and the other prisoner betrays me, তখন তো আমার কপাল খারাপ. The other prisoner will have 3 years of freedom and I will have 4 years of jail or something like that, right? So in the tragedy of the commons, যখন আমরা Nash equilibrium calculate করতেছি, it is a stable equilibrium but suboptimal from the point of view of resource depletion. Why is it stable? কারণ এখানে পরিষ্কার অঙ্কের হিসাব 40-40. I will graze 40 sheep, the other person will graze 40 sheep. But when we are maximizing the joint profits or joint value, তখন from the perspective of the commons, the result is superior. But the 60 sheep result is a little unstable. Why is it a little unstable? কার কয়টা sheep আমি তো জানি না.
Sir, for this, when harder one is, for example, he left 20 sheep to go to the common.
Graze.
So then
I will bring 40 sheep.
Yeah, so it depends on the first person's whoever goes first, then the second person.
Yeah. But so this is quite unstable.
So isn't it unfair, sir, for the that it would work for that?
No. Fairness, unfairness, এখানে কিচ্ছু আসে যায় না. আমরা যদি দুইজন একই সাথে মাঠে হাজির হই, then maybe আমরা 30 sheep raise করব. But কেউ একটু আগে, or আমি একটু আগে গেলাম, আমি আমার 60টা sheep raise করব, সে একটাও sheep raise করবে না. Right? So the equilibrium outcome is 60, but it is not stable. It is not a stable outcome. Can you see this? Right?
Yes, sir. Individually, it's not.
But in the Nash equilibrium outcome, even though the outcome is suboptimal, it is actually a stable outcome. Right? অঙ্কের হিসাবে আমার 40 sheep, তার 40 sheep. But in the joint value maximization calculation, the outcome is more optimal from the perspective of the commons, but from the perspective of the herders, it is not stable. right? Results কি হবে kind of depends on many things. It's not a stable outcome. So in game theory, you will encounter